Hello friends, welcome to the ATC Double Cut. My name is Michael Woods. In today's episode, we're going to take a look at some of the latest posts on the ATC website, and we will discuss what those are all about. One of them got a lot of hits, and that was about sand top dressing, so we'll talk about that. We'll also talk about a really cool new device to measure the cutting height with a laser line, that actually, after it goes through the prism, it makes a plane. So you have a plane of light that can identify the density of the leaf tips, or it can identify grass that didn't get cut, and it works really well to find where your height of cut is. So I think there's 4 posts that I want to discuss. We'll go through these one by one. The first one that I want to discuss is day length, temperature, and zoysia flowers. This one perhaps is of interest to me, especially because I find it fascinating that zoysia can flower all year. And you might think of this as purely a scientific question or something that is an academic concern. But it turns out to be a practical issue, because usually when we're having a sports turf or a lawn or a golf surface, we don't want to have a lot of seed heads produced in that. We want to just have leaves. And one of the problems with zoysia is the seed heads that it produces. Now, in places like Indiana or Kentucky, places in the transition zone in the United States where zoysia is used, or places like Tokyo or Nagano Prefecture in Japan where a lot of zoysia is used, the zoysia is not, the flowers on zoysia are not really a big issue, except for a short time of the year. And what you tend to see is a lot of zoysia flowers in the springtime, and then the days get really long. And as the days get long, the zoysia doesn't produce, basically it produces 0 flowers at really long days. And so it's not really an issue. And in the short days, if you're in Nagano in short days, you might be going skiing. The zoysia is not, it's not growing, it will be dormant. If you go to Kentucky in February, you can expect it's going to be rather chilly. The warm season grasses are going to be dormant. They're not producing seed heads. So when you have the short days, it's not a big issue for seed head production. But you start moving zoysia grass, or you start growing zoysia grass and going farther and farther south, and you go to a place like Hong Kong, or you go to a place like Hanoi, or you go to a place like Da Nang, or you go to a place like Ho Chi Minh City, or you go to a place like Singapore. You keep moving south closer and closer to the equator, and suddenly you have really warm temperatures when the days are short. I checked the temperature right now here today where I am, and it's 33 degrees Celsius right now, which is maybe in the low 90s Fahrenheit. And the day length today is 11 hours and 43 minutes, something like that. So it's less than a 12-hour day, and the average air temperature is quite warm. So that's what this blog post is all about. It's something that I've been observing for a long time, and I don't quite understand it yet, but I keep thinking about it and just kind of trying to figure out, is it variety difference? Are there ways that we manage the grass that might change the way that the seed heads are produced, or change when we can see those seed heads? Zoysia can grow all over the world, and I just showed flowering Manila grass in Bangkok. That was in October of 2023, and in October of 2023, the day length at that time was 12. The day length when this picture of flowering zoysia was taken was 12 hours and 26 minutes. So zoysia flowers are present like year round in a tropical climate, or they can be present year round in a tropical climate. And this is something that I'm trying to figure out a little bit more, trying to see which varieties have more seed heads, which varieties might have less. And the varieties that would have less seed heads at the cutting height that we want to use it for lawns or for golf course fairways or for sports fields or whatever, the types that have less seed heads at those desired mowing heights are going to be preferable. And then if there's something that's related to the management that allows the grass to produce less seed heads, that would be good too. Now, anyway, I kind of put this as a placeholder there and showed a Daylength chart, which I think is something that maybe people aren't. Well, I hadn't really looked at this until I calculated it, but you can have really consistent day lengths. Like where I live in Trang in southern Thailand, the day length is never shorter than 11 and a half hours. At the shortest day of the year, it's still more than a 11 and a half hour day, and it's never longer than 12 and a half hours. It's like 12 hours and 25 minutes or something like that would be the longest day of the year. And if you go to a place like Hong Kong, I looked this up for Hong Kong. In Hong Kong, you vault all the way to a longest day of the year that's almost 13 and a half hours. And your shortest day of the year is a little bit more than 10 and a half hours. And then if you go to a place like Houston or a place like Fukuoka, Japan, so there we have golf courses using zoysia like Blue Jack National in Texas, Kea Golf Club in Fukuoka, Japan, and pretty much all the golf courses around Fukuoka are using zoysia on tees, fairways, and rough. And in those kind of places, your shortest day of the year is around 10 hours, and your longest day of the year is around 14 hours in day length. And because zoysia seed heads are produced, or the production of seed heads is triggered with short days, with days that are somewhere around 12 hours or less, when you start combining short days and high temperatures, which is exactly the type of conditions that we have close to the equator, you have a situation where the seed heads can be produced year round. So I think this is really interesting, and I like to study this. So if somebody is listening to this and has some knowledge about seed head production or seed head suppression, please send me a note. I would be happy to hear from you about that. All right. So that one, I guess, the zoysia seed head one, is of interest to me and a few other people. The sand top dressing topic is of interest to a lot of people the world over, because whether you are managing a high quality lawn, or you're managing a high quality sports turf, or you're managing any type of golf turf, you probably recognize that it can really help with smoothing the surface, firming the surface, and just making an overall better quality surface. It is useful at times to apply sand top dressing. But the question is, how much sand top dressing and when should this sand top dressing be applied? If you just do it by feel, that's okay. But sometimes people wonder if they're applying enough, and it can be interesting to compare how much sand you're applying compared to some amount that might be recommended. So I shared in this post called Annual Sand Top Dressing Amounts, I shared 2 methods that you can use to quickly come up with a value for how much sand top dressing you might be expected to apply at that location. I said, if you aren't already keeping track of sand top dressing amounts, I recommend you do. Some people don't know how much sand they apply, which I find a little bit surprising these days. I admit that 15 or 20 years ago, I wasn't paying as much attention to that then as I do now, but now I just think you're putting a certain amount of sand. Why not go ahead and pay attention to how much that is? Because if you want to make the grass better year after year, then if you're not applying enough sand, you need to apply more. If you're applying too much sand, then you can apply less, but you can't really do that more or less if you don't know what you applied in the past. So I think it makes a lot of sense to keep track of how much sand you're applying. So I shared two particular ways to get a number. One of them is I said, here are some resources and calculators that can help you get started. And that's getting started to figure out how much sand top dressing you might be expected to apply. One of them is the sand top dressing and growth potential spreadsheet from Pace Turf. And this is something on the Pace Turf website where it talks about sand and growth potential. And these are based on research done by James Hempfling et al. And that was a project that they did in New Jersey at Rutgers University. And so they found when they got the best anthracnose suppression and the best conditions of the turf grass was with a certain amount of top dressing sand. And so one way that we can calculate that is check the weather that they had in that location and then link that amount of top dressing sand at that location and that weather, and then extrapolate that to other places, adjusting by the weather using growth potential, which is something that I've made excellent use of for things like fertilizer, mowing frequency expectation, and it works pretty well for top dressing sand also. So Larry Stoll developed this spreadsheet. I'm running it now because I'm the owner of Pace Turf now, so I'm in charge of this spreadsheet now, but I haven't made any adjustments to it because what it's predicting now is numbers that are based on research and on conversations and a bit of back and forth between Larry and I, which also puts these numbers in line with some of the recent recommendations from Brian Whitlark and Cole Thompson. They have an article, Light and Frequent Top Dressing Programs, in the Green Section Record, where they're recommending to put about 8 to 11 millimeters of sand per year. And this spreadsheet will make that recommendation, and it will apportion that sand over the course of the year, month by month, based on the temperatures that you have. And of course, if you're in a place that's really cold and you're not expecting so much growth, it's not going to recommend that much sand, but it does recommend those amounts of sand for some places in the world where they have a long enough growing season. So it seems obvious that if you're in Fairbanks, Alaska, you're going to have a shorter growing season and a lower sand requirement than if you're in Honolulu, Hawaii. And this type of site-specific prediction based on growth potential can be really useful. Another thing that I recommended was a sand requirement calculator. And I don't know if everybody knows about this, but this is something that I put together as a Shiny app. And this is very site-specific because it's based on the organic matter accumulation rate that you are experiencing at your location. So for example, if we take let's just go to the OM2, the total organic material in the top 2 centimeters of the root zone. Okay, that's just right at the surface. And let's assume that we're doing really modern maintenance and we decide we don't need to punch any holes. We're just going to dilute the organic material right at the surface. And maybe we'll punch a few holes just to break down into the surface and make sure the sand gets incorporated, but it's just going to be right at the surface. We decide that we don't need to go down to 4 centimeters or 8 centimeters or whatever would be typical for a coring or a solid tine. And so we're just concerned with the top 2 centimeters. And let's say that we have our, so what we're doing with this calculator lets us put in our starting organic matter percentage and our ending, and the start date and the end date, and how much sand we applied in the past. From that, it calculates what our accumulation rate was, and then it will calculate in the future for you to achieve any particular organic matter concentration in that layer, or any organic matter percentage in that layer. It will tell you how much sand you need to apply. So let's say, for example, that we started at 5% organic matter and we went up to 6% organic matter, and we went from February 3rd, 2023 to February 3rd, 2024. And let's say that we added 2 millimeters of sand over that time period. So the calculator tells us now, it says, if you have applied 2 millimeters of sand to a 2 centimeter layer of the root zone with a starting organic matter content of 5% on February 3rd, 2023, and 1 year later it was at 6%, then that tells us that our organic matter accumulation rate is 16.3 grams per kilogram of soil per year. And now we click on the sand requirement tab at the top, and it says that for us to just keep consistent at 6% with that type of accumulation rate, then we would need to add 3.2 millimeters of sand. But I can change this, and that's going to be going to 2025. So for the next year, we could change the date. Let's say that I want to change this by September. So I want to go to September, let's say on September 16th of 2024, I would like my desired organic matter content to be 5.5%. And if that's the case, I need to add 3.4 millimeters of sand. If I add 3.4 millimeters of sand, it will result in a total organic matter content of 5.5%. That's what this is calculating. So this is it's a interesting calculator that allows you to say, here's how my organic material has been changing at my site. And based on how it's been changing at my site, this is how much sand needs to be applied with that type of accumulation rate in order to adjust the organic matter content to any level. So you can figure out at your site how much sand is required. And I also put links in that post to figure out some conversions between depth and mass and volume of sand. And that it's easy to do that with, for example, you can use Google and search for it. I think probably I will add that functionality to that calculator at some point, and I'll put another tab at the top of that calculator and say, okay, if you want this amount of sand in millimeters, which is my preferred unit, here's what it would be in some other common units. And then one of my fun posts that I really enjoy, this one is titled The Annual Top Post Reshuffle. And on the ATC website, there is a top posts section. And that top post section, I list 12 posts on there. And those 12 posts are kind of like the all-time top posts, but they're not really all-time, because some of the stuff from like the the stuff that got a lot of views in 2013 or 2014, I don't really want those views to count anymore. So what I've been looking at to identify the posts that go onto this top posts list, what I do is look at all the posts, no matter when they were published, and I look at the ones that got the most views within the past 2 years. And if we do that, then it changes a little bit, because sometimes the posts that a lot of people were looking at, then they don't get looked at anymore, and so on. And so I did a reshuffle, and there were 4 posts that got added and 4 posts that dropped off the list. The list has 12 posts on it. And I think it's interesting to see which ones get added. And the 4 that got added were reflections on growth rate, nitrogen, and top dressing, which was one of the top posts last year. Organic matter accumulates more rapidly in putting green soils under these 2 conditions. And that's a post actually from 2 or 3 years ago that was not on the list, and it's now on the list. And I think this one is one that everybody should be aware of. Organic matter accumulates more rapidly in putting green soils under these 2 conditions. Those 2 conditions are, let me double check. The 2 conditions are when basically it accumulates more rapidly when there's less organic matter in the soil. So the lower your organic matter content is, the more rapidly the organic matter will accumulate, but also it is younger greens, so or younger turfgrass establishment. If you have turf that has been more recently established, it's going to accumulate organic material more rapidly. So it's those 2 conditions. And the implication is that when we manage turf to reduce the organic matter, and when we manage turf to create what is essentially an artificially young soil condition, that actually can lead to a more rapid organic matter accumulation rate. So that's an interesting one, and it's one that I would encourage people to ponder and think about. And then no surprise that the growth ratio equation post also made it onto our list of the top posts. And I suppose that one may stay on there for a while, because there's a lot of people interested in the very useful growth equation. And then just squeaking onto the list is this is a soil pH chart that I do like, which is a post from early 2023. So it's nice to see a bit of change. I'm glad that people are interested in pH and growth ratio and that organic material accumulation rate. And then, of course, the growth rate, nitrogen, and top dressing is quite important. So it's nice to see those posts on the list. Of course, we also have a few that leave the list, and these are 5 different ways to measure smoothness and trueness of golf ball roll on putting greens. And then 2 posts about core aeration, and 1 post that was on the list, I think, since about 2000. Well, ever since I started making this list. I started making this list about 3 years ago. And the 2 similar approaches to turfgrass nutrition, with 1 notable difference, has been on there ever since the start. That's a post from 2015, I believe. It's about comparing the MLSN method for turfgrass soil test interpretation and fertilizer recommendations. It compares MLSN with the precision fertilization approach of STURF, and points out how they're identical except for 1 notable difference. And that one's been up there for so long, I'm glad to see it drop off temporarily. So we'll see. Some of those are pretty strong posts about core aeration. A lot of that turns up in Google searches. And so then people will click it, and that inflates the view counts on these. So we'll see what happens. I sure enjoy writing the blog posts and seeing what people actually like to read. It's fun for me. And I suppose that this will be approximately annual. I tried to do this annually. This one, I will try to revisit in about a year and see how it is. And then one more post I want to talk about today. Again, all of the posts that I'm talking about are, of course, you can find it at asianturfgrass.com, but I'll put a direct link to all of these in the show notes so that you can find them easily. This measuring effective cutting height with a laser is an interesting one. I've written about it at Pace Turf too, or I've written about it at Pace Turf also. And I encourage you, if you're not yet a Pace Turf subscriber, do please go to Pace Turf and get yourself a subscription for $275, and you get access to all kinds of information, site-specific climate appraisal, weather updates, and all kinds of stuff that I don't post at the ATC website. So I wrote about this cutting height laser at Pace Turf first, and then I shared a little bit of information about it here on the ATC website. And I made a short video that shows how it works because people were asking me a lot of questions about it. But the reason why this effective cutting height is so useful is shown in this chart that actually comes from the Pace Turf website that I posted over there in the photo gallery. And that is the effective height of cut by prism gauge that was measured by Dr. Eric Razor. And he measured on bentgrass, Bermuda grass, seashore paspalum, and zoysia greens. He measured the stimpmeter measurement, which ranged from less than 7 feet to more than 14 feet. And there is a pretty clear relationship between the effective height of cut measured by a prism gauge, then that was one without a laser, that there is a pretty clear relationship between that and the green speed measured with a stimpmeter. And when I looked at those data from Eric, I realized that the mowing height really is critical. And I've often thought of like, okay, a double cut makes the green speed faster, or rolling makes the green speed faster, or cutting the nitrogen rate makes the green speed faster, or increasing the plant growth regulator rate makes the green speed faster, or all of these things that can have an effect on green speed. Reducing the clipping volume will eventually lead to an increase in green speed. But when you think about all of those things, the double cut, the triple cut, rolling, especially reducing the growth rate or reducing the amount of clippings that you cut, and of course reducing nitrogen or cutting the amount of water or increasing the plant growth regulator can all have an effect on reducing the amount of clippings that are harvested. All of those things, what they're really doing is they're reducing the effective height of cut. And that will then lead to a improved or a faster green speed, or more distance of ball roll across the surface. So this laser, I'll encourage you to check out this video. It's less than a minute, and it shows how the line laser, it goes through the prism, and then it shoots a flat plane of light across the canopy as this. So it's a prism gauge, but it's a special kind of prism gauge with a laser that has been carefully aligned to be right on the 0 point. And so whatever movement you make with the laser, it's going to go up. If you move it a 0.5 millimeter, it's going to move a 0.5 millimeter. And if you move the laser by 5 millimeters, it moves 5 millimeters on the scale. And so you can move it above the top of the canopy, and then you can drop it down into the canopy. And it's really cool how it shows right where it is, because it's got this red light that even in bright sunshine, you can see that the light is either above the height of cut, it's right at the height of cut, if there's just a couple tips of the leaf blades that are showing the light, or if you drop it down into the canopy, then the beam won't show on the scale anymore because all of the light is being captured or blocked by the interception as it goes through the canopy. So it's a really cool device, and I was surprised at the reasonable price of it. Also, you can buy it from the inventor, Alexander Grangs. He is the equipment and facilities manager at Shili Golf Club in southern China, in Shenzhen, and he invented this. He's producing them, and he gave this to me when I was over in Hong Kong for a seminar of the South China Turf Managers Association. And I thought, man, this is cool. I am glad that he came up with this innovation. And if you want to get one, you can go to the Turf Height of Cut website, which is turfhoc.com. And they're selling it for a reasonable price. I don't know. I think it actually pops up in whatever currency of whatever country you're in. So I'll let you check it out, what it is. But it's reasonable, I think. And I believe it can ship anywhere in the world. So check it out. I think Alexander asked me if I could suggest some improvements. And I need to use it a little bit more on low height of cut turf grass. I wish it would be, I think it would be really cool if this could be zoomed in just on something that's like 6 millimeters and below. Right now the scale goes all the way up to 40 millimeters. So, you'd be great at, you can tell something is around greens height, and then you can tell something is around tee height, fairway height, even up to, 1 inch or this doesn't go up to 2 inches, but it's up to like 1.5 inches or something like that. And it would be nice to just really zoom in on that putting green height scale. But if you take multiple measurements, that's how you can get some precision. So if you go take 4 measurements and then use your eye and you say, okay, I think this one is 2.9. I think this one I'm getting a reading of 3.2. This one I think I'm getting a reading of 3.5. And you can then take the average of those, and that's going to give you some precision. So that's a little trick when you can't get a single reading and just be confident that you're like at 2.7. But if you take multiple readings, then you can take the average of that, and that's going to give you some precision. So it's pretty cool, and it's just really satisfying and fun to use. I really enjoy using that type of a meter. So those are some of the recent posts on the ATC website. And again, there will be a direct link to all of this in the show notes. I have all kinds of fun things that I'm working on. I was recently a guest on the Thai podcast, which you can check out. I'll put a link to that episode also, which you can check out. I was a guest in late December in the end of season Talking Greenkeeper podcast. So I've been a guest on a couple podcasts talking about the philosophy of greenkeeping. We end up talking about playability quite a bit. We end up talking about playing conditions for golf, and we end up talking about a philosophy of greenkeeping or a philosophy of turfgrass management that I think is, how to say, well, I'll just listen to those and tell me if you think it's applicable to the type of turf that you manage. So that's a couple of bonus things if you want to hear even more from me. And there will be a bit more coming up. But for now, I will sign off and say thanks for listening. Thanks for watching. For ATC from Trang, Thailand, I'm Michael Woods. Bye-bye.